Firstly, we're gonna add data, and then we're gonna choose our data from the folder. This is our boundary data, and then we choose OK. This is our boundary data. Next, we're gonna add data, and we're gonna find our new data, DM data. This is our elevation data. To clip raster, and then we're gonna choose our DM data. Next, we're gonna go for boundary data for output. Then we go to click this input features and we run the data. This is the result of the data. Next, we're gonna go for the spatial analysis tool, surface, and go slope. We're gonna input our raster data with the elevation data. And then we're gonna go to degree and choose present rise, and then we're gonna run the data. This is the data that have been shown. Next, we're gonna go to spatial analysis tool, and we're gonna choose hydrology. After that, we're gonna choose field. Then we drag the data into the field, and then we go run the data. This is the result of the field data. Next, we go to flow direction, and then we're going to choose the data from the field and we put into the input surface. Then we run the data. This is the result of the data. Next, we go to the flow accumulation, and then we go to field direction, input raster. Then we're gonna run the data. This is the result of the flow accumulation. Next, we go stream order. Then we take the flow accumulation data into input stream order. After that, we go flow direction and pull it inside input flow. Then we go run the data. This is the result of the stream order. After that, we go to the conditional, and when we choose con, then we take the stream flow and put into the input conditional raster. After that, we take all the field data and put it at input through raster. Next, we select value and is equal to. Next, we choose 7, then we add more, and then we choose all. Value is equal to 6. Then we add 4 class that highest, 7, 6, 5, 4, and then we run the data. This is the result of the data. Next, we go to the stream to futures, and then we take con stream and put it inside input stream raster, and then we choose field data and input to flow direction raster, and then we run. This is the result of the class data. After that, we choose flow length. Then we take flow direction data and put it input flow direction raster. After that, we run the data. This is the result of the flow length. Then we change the color of the flow length. This is the new color of the floor light. Then we change color for the stream, and this is the new color for the stream. Next, we go to specialness tool, distance, legacy, and we're gonna choose equal distance. For this, we're gonna choose stream con, and then we're gonna run the data. This is the result of the equal distance variable distance. Next, we're gonna add our data. We're gonna choose the data from land use. This is our land use data, and this is our boundary data. For this, we're gonna go to clip raster, and then we're gonna take our land use data, put into raster, and our boundary data put into output extend. Then we're gonna click use input features for clopping geometry and run the data. This is the result of the land use data. Then go to make net CDF raster layer, and then we choose our data, that is rainfall precipitation, and then we're gonna set this format, change it into time, and then we run the data. This is our data that we got from net CDF raster layer. After that, we need to go to data and export raster. After that, we output format, we choose TIF, and then we go for WGS 1984 for coordinate system, and then we export the data. This is the result of the data. Next, we're gonna do is cell statistic. Next, we put our rain data that we change the name, and then we go to the output overlay statistic and we choose sum. This is the result after we run the process. Next, we go to the data and we go properties, and then we're gonna change the name. We change the name into rain data, and then we're gonna put the data inside the project raster, and then we choose WGS 84 for coordinate. Then we run the data. Then we go to raster to point and take the data that we run. After that, we run the data, and this is the result of the data. Next, we go to IDW and take the data before and put it inside IDW point features, and then we're gonna change it into grid code, and the output raster, the output cell size, we're gonna change it into 30, and then we're gonna run the data. This is the result of IDW that we have run. Next, we go to clip raster, the IDW data into input raster. There we take boundary data and put it output extend. And then we click the use input features and run the data. This is the data that we had. Next, we go to the raster to the point and we choose IDW raster. Next, we go run the data. This is the result of the new IDW data. After that, we choose raster, and then we go for output raster, and then we run the data again. This is the new IDW raster data. Then we go to environment and choose extend, and we're gonna choose balik in Kedah, our boundary data. Then we go to mask and choose balik in Kedah for our boundary data. Then we run the data. This is the result that we got. Next, we go to the symbology and then we check class for 5 class. This is the result of the 5 class that we changed. Next, we go to the layer, properties and change the name into precipitation. T is the last step for processing data of the float map hazard in Baling Kedah using Argis Pro.